Hello, this is Aaron Russo with DSC 478 presenting about my final class project for the fall quarter of 2022. For this project, I used the secondary mushroom data set obtained from the machine learning repository. And this data set was a simulated data set in the sense that it was synthesized based on 173 different species of mushroom, and for the data, 353 instances of each species. Each species were created for this data set as a kind of pilot for machine learning techniques to predict edibility of a mushroom. And so that leads to 61,069 instances in the data set. There's one binary class, which is the edible versus poisonous, and that's the target attribute. And then 20 remaining variables, 3 of which were numeric, and all the rest were categorical. For example, different colors, whether or not it bleeds or bruises, the veil type, things like that. And so the ultimate goal of this project was to use classification techniques to predict the edibility of the mushrooms based on the features, and then use clustering to determine whether and in what manner the data clustered. If anything meaningful came out of that. So getting into the project code here. First, I filled in missing values. There were a number of columns with well over the majority of missing values, so I removed those in order to not dilute the data set, and then I filled in the rest with the most common value by the column. And then afterwards, you did some initial visualizations. For example, you can see that the classes are balanced, etc. Afterwards, I split the data into 80-20 training test sets after splitting off the class variable, then built out the dummy variables, and last scaled the data using min-max scalars so that all of the variables were on a scale of 0 to 1. So the first technique I tried was KNN, and for KNN I used the scikit-learn version. First, for the training set, I ran for different values of k, uniform versus weighted, and we can see that the classifier performs very well, especially with weighted distance, and around k equals 5 looks like the best. So it took weighted distance and compared the performance on the training and the test set, and we can see that value of k equals 5 still performs the best on the training and test set, and as we increase k, we get a little bit of overfitting. So ultimately, KNN performed extremely well on this data set with over 99% accuracy, and you can see it performs pretty much equally well on both classes. Naive Bayes was next and didn't perform quite as well. You can see, not anything close, around 72% accuracy. And that can be, partially maybe due to the fact that there's some multicollinearity in this data set, especially with the dummy variables. Then LDA was performed, kind of similar performance to Naive Bayes, not very impressive, indicating that maybe the data doesn't separate in a linear fashion very well. Next was decision tree classification. And the default tree performed extremely well, comparable to KNN. We can see, 99.8% on the test set, 100% on the full training set, and the cross-validation score was extremely high as well. And so what I wanted to do with this was do a classification report. We can see that it's performing pretty equally. The one thing with this was that the tree was quite complicated, and so what I wanted to do was see if we could get a simpler tree in order to make this more, usable as a sort of field guide or something like that. And so what I did was, first I tried entropy versus Gini, and then I tested different values of max depth to get a more simple tree. And we can see that around 15, we're still getting really, really good performance. And so it might be useful to use a simpler tree with a max depth of 15 or 16, for example. It still performs incredibly well. And then lastly, for classification, I used random forest. And after some parameter tuning with the N estimators, I was able to get it to perform 100% on the full test and training set. And then lastly, clustering was done. And initially, with clustering of with 2 clusters, it performed pretty horrendously. Silhouette score was very low, and the completeness and homogeneity score were near 0, indicating that these clusters were essentially random. But so that that indicated that the data doesn't cluster based on the class. But what I was curious about was to see whether it would cluster based on species. And so what I did was increase the number of clusters to 173, and we can see that silhouette score increased quite a bit and homogeneity score increased, immensely, which indicates that the data really clusters really well on the species level, and the homogeneity score is really high in the sense that species that are edible were being clustered together and species that were inedible were being clustered together. So in this sense, k-means clustering with 173 clusters actually performed better than LDA and naive Bayes.